You should be in radian mode. Remember, if anyone's borrowing your calculator for pre-cal, they're going to probably put it in degree. For those of you guys just joining us, they had about 7 minutes to try it on their own. They had about 3 to 5 minutes to check it in their groups, and now we're going ahead and grading this FRQ. So pause it and try it if you have not yet, the one I handed out yesterday. But for those of you guys that have tried it, we were just talking about this intersection. Actually, technically, this x-intercept, the one on the far left, that bounded region R. Could you guys have done right minus left? What am I saying? Right minus left would be in terms of what? Y. Do you want to solve for x? So would you? Could you? No, you couldn't have done right minus left. In the region, yeah, it would have made sense. You could have done right minus left, no big deal. There was no revolving. There was no perpendicular slices. This was not volume. It was old school section 6.1, top minus bottom or right minus left, with our little slivers, our little representative rectangles. However, there's no way we're getting this in terms of y. No, 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 no. So we're going to do top minus bottom. But to do top minus bottom, you need x bounds. That's why we're finding this intersection point. So you should have put this in your calculator. Now pause. I want you guys in your calculator with this graph shown. Zoom standard is sufficient, true? But couldn't you have changed your window to make it a little bit more like what you see? Or could you have changed your window to zoom in on this and make it look exactly like theirs? What could your x-min have been? -3, sure. -3, -2. What could your x-max have been? 4 or 5, right? You can use the graph, and you can make it in your graphing calculator the exact same way they have it, so you're looking at the exact same picture. So you can go x-min -3-ish, x-max 5-ish, y-min -3-ish, and y-max, I don't know, 4-ish. Anyway, that's just a quick little trick as far as making yours look exactly like theirs. But long story short, find your 0. I think Mrs. Leon was saying something about Honors Chem was having to find zeros the other day for something. Find your 0, go a little bit left of the 0, a little bit right. Remember, they're asking these questions. Okay, is your calculator right now identifying, showing you the 0? Cool. Ready? I want you to hit the buttons in the order I tell you. Second quit. Stow. Do you find the stow button on the left-hand side? And then do alpha A. And then enter. Guess what happens now every time you do alpha A? You can just give them if you know them. Yeah, yeah. Thanks, bud. Yeah. Yeah. What happened? Now hit alpha A, enter again. Who's alpha A? Ah! You don't have to type this over and over and over again in the FRQ. You can stow it just like they did. You can say A is equal to. Yeah, you can. Or B is equal to, or C is equal to. Yeah, you can. So now when you go to do an integral, guys, do an integral from A to 0 of, didn't you just put it in Y1? How do you find Y1? Oh dear. Alpha trace, right? Alpha trace equals. Quickly. Guys, we're groups. Why aren't we showing it to people that don't have calculators and making sure that they're good? Poor Ruth is just like staring there. It's like kind of looking on. So after you stow this, can't you then go ahead? Now, I had you guys put it in A. They put it in P, whatever. But you can change this to an A. It's not a big deal. Not a big deal. Not a big deal. You just have to make another letter down here. But A to 0 of y1 of x dx. Now question, on the FRQ, should you put y1? No. What did they call this function? F. So we're going to put F in like our actual wording, in our actual notation for our answer. But guys, do you see how easy that was? You have it graphed anyway. Why would you type the whole thing out in your integral and waste precious time? Put your y1 in there, go from A to 0, and then dx, and go. Did it work? Booyah, 2.903. Is that cool? Did anybody have any issues finding the buttons, finding what we were doing? Collaborate in groups if so. How easy was that? How many points could that have been worth? 2 out of 9. Sweet. Hey, when I'm grading the mock AP, I'd much rather have a 2 than a 0 out of 9. Yeah? And guess what? In this one, if you had gotten the bound wrong, guess how many points you got? None, because your integral would have been wrong and your answer would have been wrong. Bummer. All right, letter B, in grading. Wait a minute, so what if you have the bound wrong in letter B? Oh, we get no points. Hold on, pause. Isn't there a separate point for the limits, aka the bounds, and the constant and the pi? Now, even if you put the pi, you still would miss this point if you did the wrong intersection, so you still would miss that one. But could you still get 2 points for having the right integrand? Yes. Okay, so this one's a little bit nicer. They spread the points out a little bit more. So even if you got the wrong bound, you still could have gotten 2 out of 4 if you properly did, whoa! Is this a big R squared minus a little r squared? Is this a washer? Did you guys figure that out? Where are you revolving? Well, what region are you revolving? Must be R again because you have the same bounds, right? Where are you revolving R about? Y is what? Because it's R that's being rotated. Oh, but we see the, no, because it said R. So I was actually just about to go there. We do need to draw our axis of revolution, right? So y equals -2, true? But you have to pay super careful attention to the English, right? It is revolving about this. I am going to have a dx. As we've seen, it's a horizontal axis of rotation. But this R region is what's being spun. According to the wording, R is being rotated. I am not extending this. I am not finding any more. It did not say, like, let's redefine what's being rotated. It says, no, that's being rotated. So it has to be a washer. Does that make sense? Yeah. So I'm using the exact same bounds from A to 0. I'm rotating this. Now, guys, hold on. We worked on this really hard yesterday, yeah? Who's my big R? Where do we always start in drawing our radii, our representative one? Always start at the axis and then go through the area to the outer region. So am I going up, right, left, or down? Up. Okay, so follow your axis. Extend up for our sliver of our cross-sectional slice. That's my big R. Now, is it this big R? No, that's, okay, fine. No, they have a big R. Whatever, we can name it big R1 if we want and then make it different than that big R. But that's my big radius. So, who's on? Yeah, the y. We're going to use what they call top. And what's on bottom? Y equals -2. Awesome, it's not hard, right? So my big R, or you could say my whole radius, if you want to do it that way, is equal to f of x minus -2, right? So do you see f of x plus 2 being plugged in for big R? Who's my little r? I'm going to use green, sorry, awkward. My nice pretty one's over there. From the axis to what? The edge of the hollow. Sorry, that wasn't straight. Remember, it should technically be in line so that we can see like the actual washer. With it would be that big metal disc and then the hollow being punched out. But that's going to be my little r, right? And my little r of my hollow. Who's on top? 0. You see it? Who's on bottom? -2. Do you see +2 being squared for the second piece? So I have my big R squared, that guy squared, minus my little r squared, which ends up being 2 squared, which is 4. And they said, booyah, we got it. Go get your decimal. Pause. Look at your work. Are you writing dx's? If you're not, you have to take away a point that you just gave yourself. I know, but it's true. For the integrand, if you didn't put your dx, they're going to say, sorry, something illegally stated. I can't give you that full credit. But if you were able to do your washer, I can't get that box. If you were able to do your washer, even if your bounds are wrong, you could have gotten those 2 points. Any questions on grading so far, A or B? Or on the solutions, A or B? Wait a minute, how could you plug this into your calculator? Pause. Would you leave that till later, or would you put it first? Put it first, or else you're going to get a wrong decimal, right? The odds are that you're going to forget. So pi, can't you use your A to 0 again? Now be careful of your parentheses, but couldn't you do y1 plus 2 quantity squared minus 4? Got it good? Cool. Why is C harder? Yeah. Yeah. What do you need to do S? F, we already have F, but what else do you need? Careful, it's not a T. Isn't it an L? Is it an L? Who is L? Did they tell us anything? Ooh, L, line tangent to the graph at 0. Isn't this semester 1 stuff, guys? Equation of a tangent line? So how on earth did they get that? Isn't the equation of the tangent line? Well, you guys, come on. It's a forever card. What do we got? Equation of a tangent line is what? F of A. And who is my A if it says at 0, the tangent line? F of 0 equals F prime of 0 times x minus 0. Oh, man, this is rough. Pause. Go to your home screen. You have y1 in there. It's easy. Go get your y1, put a parenthesis, put 0, put a parenthesis, and put equals. Can't you plug in super fast without even thinking about it? I mean, yeah, you could plug in and say, oh, it's 0, 0, 0. I hope I remember cosine of 0 is 1. But can't you just do y1 of 0? I'm trying to help you out, yeah? What's y1 of 0? 3. Good. Which would be 0, 0, 0. 3 times cosine of 0 is 1. 3. But either way, now you know for sure it's 3. So I have y minus 3 is equal to, oh man, I had to take the derivative. Pause! What's in your math menu? Go to math. Go down to n derive, right? Take the derivative of y1 at 0. Guys, it's a calculator problem. They're giving it to you. Liz, do you know what's going on as far as the options? You can turn. Nick, do you know what I'm talking about? Like which ones? Okay. Math. Go to n derive. Take the derivative of y1 at x equals 0. I'm guessing it's negative 0.5. Is it negative 0.5? Sweet. How do I know? Because I'm looking at the answer. But what ends up happening? You get y minus 3 equals negative 1/2 times x. What'd they do? Moved it to one side. Why did they move it to one side? Because go put it in y2 and get your tangent line that you can find an intersection with on your calculator. So go to y equals, throw it in y2. How are we doing? Does this seem impossible now? But how many of you, just raise a hand, be proud, be confident, we're like, yeah, I was confused earlier. Okay, but does it seem impossible now? Where you're using your calculator to its fullest extent? Maybe not. So go throw in that tangent line, graph it. Can you guys now see this picture? Can you see it skimming at 0? If it's not skimming at 0, you did something wrong. But we can add the 3 to the other side, negative 1/2 x plus 3 or 3 minus 1/2 x, whatever. Just by getting the tangent line equation, you got a point. Sweet. Integrand. Wait, we're integrating? Oh, because we're finding area. Okay. Area of S. Guys, we already said we're doing dx. So if we're doing dx, we're doing top minus bottom. We need x bounds. One x bound is 0. That one's easy. What's the other x bound? What should you be doing? Intersect, yeah? I see some people going to their calculators. If you do intersect, can't you do my cool trick of stowing it as a variable? That's exactly what they did, except they and theirs called it A. Well, we can't call it A because we called our other one A. So you have to be consistent in whatever you're doing, but it's okay. You're not going to have the answer key you're trying to match in yours anyway. I see that question, AJ. Let me just label this B real quick. I mean, you can store it as A, but since you already assigned A somewhere else, I would just store it as like alpha B. And that way, if you needed to go back, I mean, it's up to you guys, but let's say you finish all of your FRQs, you're going back through and double checking everything. I mean, it might not be bad if, like, starting at FRQ1, you were stowing like A and then B and then, well, you only have 2 FRQs with the calculator anyway, but it might not be a bad idea if you keep on moving in your letter progressions. That way, if you need to go back and check, you have it stowed so you know what you did. But, I mean, you're supposed to write it down anyway, so. And you could technically have written 3.389. Wait, why are they doing more than 3 decimal places? I don't get it. All of calculus, only 3. Is this the final answer? They're saying, no, 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 include more. Only round at the end. Now, you could have written all of them. You could have done a dot, dot, dot if you wanted to, and then like you're using hopefully the whole decimal. But wait a minute, how'd they, oh, top minus bottom. Wasn't the tangent line on top? And wasn't the curve on bottom? Can't you do tangent line? Or wait, can't you just do y2 minus y1? Or couldn't you do any subtraction with an absolute value and be like, oh, they're not asking you to solve it. Careful, careful. If they're just asking you to write the integral expression and not solve, if you accidentally flip it the other direction, just make sure you put those absolute values in, okay? But hopefully we can look at the picture, see top minus bottom, and we're done. So 1 point for getting the correct tangent line, 1 point for getting the correct top minus bottom. And even if you didn't know the tangent line, couldn't you have done L of x minus f of x? Couldn't you have gotten that point without even knowing what the tangent line was? Are you seeing how we can kind of work the system a little bit? Even without knowing the intersections, maybe you could have done the washery bit and gotten some points for the integrand. Without even knowing exactly the bounds or how to find the tangent line, you're like, well, I know it's supposed to be tangent line minus f of x, so I'll make up some stuff. Give me a point. Don't make up stuff like write them a paragraph about how hard your night was or how hard calculus is. They're trained to be like, they didn't try. Like literally, they'll skip over, they won't even read it. Which some of you are like, well, that's sad because I've actually tried to make them on my side by writing like a sob story or drawing a really pretty picture. For them, they're just like, that's easy. Don't have to grade that one. Let's keep going. They have to be little machines when they grade, sadly. It's super intense, like all day, every day for a week. All right, cool kids. We need to grade some homework for section 6.2, yeah? And you guys need to ask some questions, etc. But let me go ahead and pause the video. It's done. Here we go, section 6.2. Whoa! Did I not rewrite your guys's? I didn't, did I? Okay. Stink. I totally forgot that this year. In past years, I had rewritten the homework so that you would have tried the cross sections first and then the discs and washers, but I had you guys watching the online tutorial things anyway and doing those extra examples. So we'll get to number 70 when it's proper. Sorry, your first even should be number 10, right? Okay, we'll get back to question number 6. Oh, okay, 6 is the first one. All right, 6 was a by hand one. I know. Well, was it in your count or was it a calculator one? It was a by hand one. So by hand, you should have gotten down. Now, wait a minute. Could you have stuck it to the man? You could have. You could have gotten all the way down to here. And then you could have boxed it. Or if you were really amazing, you could have gotten common denominators and gone further. But I wouldn't have judged if you had stopped here. So let me give you a second to go ahead and check and make sure that you had your proper, ooh, how do I know it's a washer without even looking at the picture? What do I see in here? Big R squared and a little r squared. See it? A big R squared and a little r squared. Whoa, magic math, what did they do? Was there symmetry on this area? You guys should be able to look at your picture, right? Was there symmetry? What was on the right was the same as what was on the left? I saw it because of the bounds, or at least I guessed it. So they're like, oh, I don't want to plug in both of these because they're gross. It'd be a lot easier to be able to plug in 0 for a bound and just say double. You can do that? Yeah, remember we talked about even symmetry? We talked about that with area also. If they're symmetric, we can just take half of it and then double it for volume too. Then they went ahead and they had to FOIL and they had to combine like terms. Then they had to, are any of you finding on the Chapter 5 test that you forgot to anti-derive sometimes? I'm not saying all of you, but some of you. It's easy to get so stuck and then forget. You have to anti-derive, plug in top bound, plug in bottom bound, box it, you're done, that's fine. Box it, you're done, that's fine. If you're like, wait a minute, mine looks different than theirs, but I think I'm right. It's okay, write down 132.69. There should be a third decimal place and compare. Number 10. Why do I know that it is a disk just by looking at it? Pi r squared. Do you see it? Do you see the difference? It was a disk. It should have been flush against the axis. Was this one a by hand or a calculator? Nice. So then you can go ahead and throw in. Remember, it was every third one. Oh, it was by hand. That's right. Lo siento. It's okay. You guys could have foiled, right? You didn't kill any puppies. You should have had 3 terms. Anti-derive, plug in the top, plug in the bottom. And technically, you could have boxed it and been done. So if you want, you can go ahead and throw in your answer, throw in their answer, check the decimals. As long as the decimals match, your stick it to the man would have been fine. Can someone get the decimal for us really quickly? That way people can check it later and make sure they're right. 95.133. Nice. So if you guys want to write down 95.133? 0.133. That's the correct decimal. You can plug in your yucky stick it to the man answer. Oh. Double check. 96.133? Got it. Sorry, 96.133. Thanks, Grace. Number 40. That's past 35. This one's definitely a calculator one. 3.233 is enough, but I guess you could have kept going. It should have been a disk. Number 44 should have been a washer. Do you see the big R squared and the little r squared? Did you guys do top minus bottom was 1 minus 0 for big R? Oh no, this isn't top minus bottom. This is right minus left. How do I know that? dy, dy, dy. You were rotating around a vertical axis. And it should have been around the line x equals 1. Right minus left, 1 minus 0, and then right minus left, 1 minus y. Big R squared, little r squared. I told you guys you could use your calculator, so if you want, you can go ahead and throw in 2 pi. Does anybody have that one? 2.094. If you guys want to write it down if you didn't get it. 2.094. Number 46. You guys tell me, what is this? It's a washer. What kind of axis are you rotating it about? Good. Horizontal one, and specifically, isn't it y equals 1? So top minus bottom, big R squared. Top minus bottom, little r squared. And then I, once again, said you could go straight to the decimal answer. What did you guys get? 0.628. Anybody back her up? Nice. We doing okay? Number 54, you're matching. A was washer, 2. B was washer, but with horizontal, that was 4. C was number 1, and then D was number 3. So 2, 4, 1, 3. Okay, let's go find number 70, because not number 74 next, right? Number 70. Number 70 was, cross sections. They came in. Oh my goodness, it's taking forever. Oh, there he is. There you go. Number 70, I mean, you guys don't need the picture. You don't need the region, so here we go. Letter A, final answer, 81/10, which would be 8.1. I can do that decimal in my head. Letter B is 9/2, or 4.5. This was one of those rectangle ones, base times height. Heights, I think they said, were 1 for the rectangles like we did in class. Base was top minus bottom. Yeah, because it's dx. Now, guys, you might not have written it like this. You might have written it like this, and that's okay, but it should have ended up being the same thing, right? If you wrote it like this, you're okay. They just simplified it before they plugged in. Whatever, they do what they do. Nasty thing is they did it by hand, but I said past 35, you could do it in your calculator, so as long as you set it up right, you should have ended in the same place. And once again, yours might not have looked like that. It might have been this minus this squared. That's okay. That's fine. Just make sure you got 8.1 and make sure you got 4.5. Was there a C? Oh, nope, that was it, right? Okay, so let's go back to number 74. B. B as in boy. B as in, I don't know. Brave? There you go. Banana? Sure. Breakfast is on the mind. Breakfast! I like breakfast. Are we done? All right, guys. If you haven't yet, go ahead and write down the test review. The book review, this is due on Monday. I know there was some mix-up in Google Classroom. For some reason, I posted it twice. I don't know what was going on. But I got rid of it once I got a couple emails. Thank you, Grace. Thank you, AJ. And cleaned it up nice and pretty. Test review is due on Monday. We're going over the test review after the Forever quiz. But as you guys are writing this down, do we have any odds especially? Because the evens you just saw, maybe you haven't had time to think about it, that we have questions on. Ale.
Can you actually go up to this?
Oh, do you need to see it for a little bit more? Yeah. There you go. It was a washer with a horizontal axis with a horizontal depth, dx. Top was 4. Actually, this is a good one to show. We did one like it yesterday. would have top minus bottom would be our big R. Sorry, it's a big old highlighter. But top would be 4, and bottom would be our 4x squared. 4 minus 4x squared is big R. And little r would have been, I'll have to use a different color, sorry guys. Little r would be top, which is 4, minus bottom, which is 3x. Do you guys see a typo in their work? I see a typo. Got it. Does that change the answer, or does it still match with B okay? Okay, it still matches. Sorry for the typo, though. Yeah, it definitely should have been 4 minus 4. That was a typo on their part. So for all that, their magic math, they still make mistakes. Okay, sorry, so back to the test review. Choop, choop. Ollie, you good?
Yeah.
There we go. All right, let me freeze it. I'm still ready for questions, though. Do we have anything? Yeah, Ryan. 31.
13.
13. We'll start at 13. Of 75? 19. Let's go 13, 19, then the 30s, and then the 70s. And if you guys have anything else, we'll peek at it, okay? Pause. If you're bored, what could you be doing right now? Grabbing a book and working on the test review. No directions, no problems, just working it out. All right, cool kids. With that, zoop, zoop, let's go find number 13 was the first one. Why aren't you working? Hey, buddy, come on, wake up. 13, wait a minute, there was a video to that one. Okay, I'll just set them up and I'm not going to solve them. Because we did number 14 like it yesterday, and then there was a video that I needed you guys to check out, or I made it so you could check out. Wow, it's frozen. Sorry, hold on. Let me try one more time. It's not zooming in, zooming out. There we go. Okay, guys, you got the region. Oh, it was a basic graph. Okay, did we get the area, the region that we were supposed to be spinning? Hopefully, right? I'm going to need to probably get this into our notes to be able to work with it. I can get rid of, I think, all those pages. Let's get rid of that one and that one. That one was still kind of helpful. That we haven't done yet. Okay, here we go. Okay, the region that we're rotating. P.S. If anybody got number 13 and doesn't have a question, can you go grab one of each of the handouts, one of each for everybody in your group? The office didn't staple it. I'm sorry. I'll pass around a stapler in just a little bit, but go grab one of each of the handouts for everybody in your group, if you're good on 13. Thanks, guys. Okay, what do we got? We have square root of x from 0, well, actually all the way up to y, x equals 3. I can do a different color for that one to help us out. So we have x equals 3 right there. We have y equals 0 right there. So then hopefully you guys would see what your region would be that we were rotating, just like we saw yesterday with number 14. I'm going to pull out my r's really quickly, but when we're going around the x-axis, that's going to be a dx. When we're going about the y-axis, that's going to be a dy. When we're going about x equals 3, that's going to be a dy. And then when we're going about x equals 6, oh, it's just another x value. Okay, cool. Just this one's going to be a little bit weird because we cut it here, but we revolve it way over here. Okay, when we're going here, our r is going to be from the axis out, and we have a disk because what's true? Flush. When we're going here, axis out, we're going to go axis out. Oh no, I have hollow space. So what do I need? Not just a big R, but also a little r. Okay, when I'm going here, axis out, it's going to be axis back. It's going to be a disk because I'm not going through any white space, unlike that one. So it's going to be a disk. And then here, axis out. Oh, what do I have, though? I have white space. So what do I need? Little r. Do we see patterns? So then when I go to solve for my integrals, I'm not going to solve. I'm just going to set up. This one, x bounds, so 0 to 3, like we can see here clearly. Top minus bottom, I'm allowed to be in terms of x. So my top is going to be my square root of x. My bottom is going to be 0. This one, I'm going to stagger it just to make it a little bit easier. V equals pi times. Sadly, now I'm in dy, so I have to think about my y's. To think about my y's, I have to think about what's going on when I plug in. Sadly, when I plug in 3, I get root 3. So it's kind of ugly, but it's all right. We can deal with those types of values too. So I'm going to go from 0 to root 3, y on bottom, y on top. But I'm going to need my big R squared minus my little r squared. Big R squared is going to be this line, x equals 3, to that line, x equals 0. Otherwise known as 9, minus little r squared. Ooh, but I don't want it like that. I want it like in terms of y. So that'd be y squared minus 0. Lost my bound. This guy's going to be nice. He's going to be a disk, but he's going to be dy. All of these are, sadly, vertical axes of revolution. So I have my pi. I'm still going to have my 0 to rad 3 because I'm using my y bottom to y top. And if you want, I can actually put that here if that helps. Rad 3, 0. Right is going to be, isn't that the line x equals 3? 3 minus my function. So right minus left squared. And then this one's going to be the washer still with dy, so still from 0 to root 3, but I have a big R squared. Who is this guy? 6. Okay, 6 minus the function. 6 minus y squared, minus, and then 6 minus, who's this guy again? 3. We're having to ask ourselves questions after we draw the situations of who's on the right, who's on the left, or who's on the top, and who's on the bottom. And wherever it is, just go figure out from the picture or from the givens what to plug in. Does it kind of make sense? Okay. It's a lot of math right there, but that's why we spent so much time on number 14 yesterday. I heard number 17 next, right? 19. Thank you, thank you, thank you. Oh, but did you guys check out 17 to help you on 19? Because it was a video? Okay, number 19. Shoop, 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 shoop. The goal and the directions above before I lose it. Find the volume generated by... Ooh, they tell us what to revolve it around in the directions, aka if you didn't read the directions, how lost would you be? Very lost, because what are we revolving it about? Okay, but now that we have the directions, mention to check out the video for number 17. This guy, doesn't he have a vertical asymptote at -1? Is that right? 3 over? Yeah, he has a vertical asymptote at -1. And somehow he's a swoop, there it is, something like that, right? Because 1 over x, basic. And what are my boundaries? I have this guy, so y equals 0. I have this guy, so x equals 0. And I have this guy, x equals 3. Did you guys figure out your region? That was bounded by all 4 of those. Did you figure them out? One, the other part that's held in by all 4. And then you're revolving it about y equals 4. Isn't that like way up here somewhere? Now we might need to find some things, like if we were to plug in 3 to this, 1 plus 3 is, oh, okay, that's kind of awkward. That's going to be the point 3 comma 3/4. If we were to plug in 0, well, isn't that just 3? But either way, 4 is above. Maybe not as above as I put it, but whatever, we could still, unless it just doesn't want to move. I would move it down a little bit. But still, guys, big R, little r. I'm not sure I'm going to be able to take time to write it out. But big R, isn't it top minus very, very bottom? And little r, wouldn't it be top minus bottom? So big R of x, because I have a horizontal depth, would be 4 minus 0. And little r of x would be 4 minus 3 over 1 plus x. Plug it in your washer formula. Boom. Got it. X is from 0 to 3. Kiddos, what do you need to do this weekend? Get down your forevers and your test review. And with extra time, I gave you 4 new FRQs to play with, yeah? Now, are the FRQs due Monday? No. Start in the book, start in the test review, get those forevers down. But Monday and then Tuesday, I can cover a couple more questions on homework and see how you did on the review. P.S. Find a BC friend and be like, areas, volumes, you need to know it too. Tutor me, please. Bye.